Hello guys and welcome to our channel for the greater good. Today we'll be studying Kirchhoff's current law. Kirchhoff's current law or KCL states that the algebraic sum of currents meeting at a node is zero. It can be better understood with the help of this diagram. Current I1 and I2 are moving towards the node and I3 and I4 are moving away from the node. It can be also said that the currents moving towards the node will be equal to the currents moving away from the node. Kirchhoff's current law is used for nodal analysis. We will take a look at two examples of nodal analysis. Number one will be a simple circuit and number two will be containing a supernode. This is our example number one. We have to calculate the nodal voltages using KCL. We'll assume that all currents are moving away from the node. At node 1, V1 minus 0 over 2 plus V1 minus V2 over 4 minus 5 is equals to 0. Simplifying this equation, 3V1 is equals to V2 plus 20. At node 2, V2 minus 0 divided by 6 plus V2 minus V1 divided by 4 plus 5 ampere minus 10 ampere is equal to 0. Now we'll compare both the values of 3V1 from equation from node 1 and from node 2. Upon comparing both the equations, we obtain the value of V2, that is 20 volts. When we put the value of V2 in any of the equations, we'll put it in equation 1 in this case, the value of V1 will be 13.33 volts. These are the nodal voltages we had to calculate. So the concept here to understand is why have I written V1 minus V2 at node 1 and V2 minus V1 at node 2. And this can be understood with the help of KVL. So when the current is moving away from node 1, we get V1 minus V2 through KVL. And when the current is moving away from V2, we get V2 minus V1 is equal to 0. In this example, we'll be studying a supernode. In circuit theory, a supernode is a theoretical construct that can be used to solve a circuit. This is done by viewing a voltage source on a wire as a point source voltage in relation to other point voltages located at various nodes in the circuit. Relative to a ground node, assign a 0 or negative charge. Here 2 volts is situated between V1 and V2. This is a supernode highlighted with red color, and the one highlighted with the yellow color will be ignored. Portion will be ignored while solving the circuit. So applying KCL at the supernode, we get V2 over 4 plus V1 over 2 minus 2 plus 7 is equals to 0. The resultant equation will be 2V1 plus V2 is equals to minus 20. If we apply KVL at the supernode, we get minus V1 minus 2 volt plus V2 is equals to 0. So we have got two equations. We now solve them simultaneously. So 3V1 will be equal to minus 22 volts. Subtracting 22 from equation 1, 3V1 is equals to minus 22 volts. V1 is equals to minus 7.33 volts. From equation 2 we get V2 is equals to V1 plus 2, V2 is equal to minus 7.33 plus 2, V2 is equals to minus 5.33 volts. So the two nodal voltages are minus 7.33 volts and 5.33 volts.